Hello and welcome to the APSCC 2020 live series. I'm Christopher Slaughter and I'm your host for the ongoing webinar series that we're presenting in place of our annual conference here at APSCC. In just a moment, we'll be looking at satellites' role in 5G, stitching together the network of networks. Today's webinar is brought to you by GeoShare. I'm very appreciative of their support for the conference series and for APSCC in general. In just a moment, you'll hear from Blaine Curcio from Euroconsult. He'll be moderating today's panel discussion, which features Lon Levin from GeoShare, Raymond Chow from AsiaSat, and Wang Peng from Galaxy Space. We'll be looking at the latest developments in the 5G space and satellites' role therein, as well as looking at prospects for the future. I hope you enjoy the webinar.
Okay, good morning, good evening, good afternoon, everyone. This is another episode of the APSCC 2020 online webinar conference. Today we will be talking about satellites' role in 5G, stitching together the network of networks. I'm joined today by three excellent panelists. We have Lon Levin from GeoShare, Raymond Chow from AsiaSat, and Wang Peng from Galaxy Space. And I'm Blaine Curcio from Euroconsult. So before getting into satellites' role in 5G, let's just quickly define what is 5G and what are the two main types of terminology that we'll be using today. So 5G is the next generation of telecommunication standards, and the two main areas that we'll talk about today are the 5G network and the 5G applications. So the network refers to the infrastructure that is built out to support the application. So you have a standardized telecommunication network. We could talk about this in terms of the number of gigabits per second of throughput that it delivers to a site. We could also talk about it in terms of latency, but basically the network is infrastructure that is built by telecommunication companies or satellite operators. Then the applications, broadly speaking, are ways that people can use this 5G network for different things. And I've heard a lot of times people mentioning that 5G is not just another G, that there's going to be this really this revolutionary number of new applications like autonomous vehicles and distance education and all kinds of interesting things. So again, digressing, today we will discuss both the network and applications, and we will try to keep those somewhat separate, although there's inevitably some overlap. So getting into discussion on the network. So the 5G networks compared to 4G or 3G are going to be denser. They're going to be higher bandwidth. They're going to likely be in smaller geographical areas. So we see nationwide 3G coverage. We see nationwide 4G coverage, even in a lot of very large countries. 5G, because of the density of the network and because of the associated cost in building the network, it will likely be less widely distributed, primarily targeting major cities and then moving out from there. So for the first question, and we can start with Lon and then go down to Raymond and Wang Peng. So I guess, what do you see the 5G network looking like, and how do you see satellite best integrating with the 5G network? Or specifically, how do you see GeoShare, as it were, or your company integrating with 5G network? So Lon?
Well, again, to be clear, and I'm going to stay at the higher level where, what I see the industry doing, because we are part of the industry. Happy to share with you our own GeoShare visions, of course, but it's the same. It's that there's great opportunity for satellites, all satellites, GEO, MEO, and LEO, but, we focus mostly on GEO. However, you pretty much laid it out. The opportunity for satellites, because 5G is going to be mostly not necessarily spreading out more. It's just going to be, as they say, it's going to be getting more and more denser, or the latest buzzword is densifying in in urban and suburban areas. We don't see it going much past that, at least the next 5 years or so, which leaves an opportunity for satellites who can pick up and serve the nodes. The nodes are the smaller antennas that are going to be needed, antennas, the smaller devices, transmit and receive, that will be providing 5G. We see satellites as being the alternative distribution to those nodes as we get 5G further and further out. So we've identified the exact reason why we think satellite has a great opportunity here. It's because things are going to be much more dense within the cities to build out 5G. That allows for satellites. The other opportunity, and there are plenty of them, is also the inter-satellite links. This allows for more secure networks to the extent that people want to have a more secure 5G network. I do want to point out, by the way, that every generation has been revolutionary, and this one is just another revolution. Maybe the greatest one, but it's still just one more step.
Yeah, no, that's a good point. And I think we tend to kind of underestimate how big of a step that was, let's say, from 3G to 4G. I mean, we walk around now with HD video streaming all the time, and we think of it as just completely casual,
Right.
like everyday thing. And on 3G, I mean, I don't think you could do, I mean, you couldn't do that. I mean, yeah, so that's a fair point.
3G was the beginning of the mobile, 3G was the beginning of the mobile internet, which was extraordinary for its time. And by the way, the 2G was amazing from analog to digital mobile. So things keep on moving on.
Yeah, I suppose,
anyway.
Yeah, we tend to underestimate how revolutionary those previous phases were. So yeah, that's a good food for thought. So Raymond, any thoughts from you on what can satellite do to make sure to get a piece of this latest revolution that we are witnessing in 5G?
Well, I mean, Asia says we operate 7 GEO satellites, right? And I think at this moment, I definitely agree that there's ways that we can actually contribute when it comes to providing the ground infrastructure as well as the network connectivities between different nodes. And right now, as they go from the urban to the rural, satellite still gives a very solid solution for them to quickly and efficiently roll out the services to different areas. I think that the challenge is actually, as we all aware that 5G, the bandwidth is significantly higher, and how do we overcome with the resources that we have right now is always a challenge for geo operators. Is that a conventional satellite, or even currently the HTS that we are having right now is capable of delivering the services that the 5G operators are looking for, mobile operators are looking for? I think that's something that the satellite operator needs to think about and try to complement each other.
Okay, thank you. And Wang Peng?
Okay. As Galaxy Space is working on the broadband LEO satellite design and applications, so we think it's very important to connect our satellite system into the 5G networks today. We know that actually 5G is quite different from the 3G or 4G, not only because of it's faster and smarter, but also it's a network of networks, not just for the individuals or customers. So we have, Galaxy Space just launched our first satellite January this year, and we have actually make some experiment with the 5G network operators to see how we can use the LEO satellite with current 5G infrastructure. So basically, we think we need a lot of collaborate between the satellite systems and 5G networks. Yeah, so we make the network more smarter networks. Yeah.
Understood. And I believe that the satellite that Galaxy Space launched this year was using Q and V band capacity. Is that right?
Yeah.
Okay.
Yes.
So just to transition into a somewhat different topic. So for frequency bands in the 5G network, I mean, we have, again, this much higher bandwidth network, and so you will likely need to use higher frequencies. Do you see Q and V band as being, I guess, the most appropriate frequency for 5G integration, or how do you, I guess, look at different frequency bands in terms of their potential to integrate with 5G? And we can start with Wang Peng, and then the other panelists, if you have any thoughts, that would be appreciated also.
Yeah. Yes, as you said, we are using the QNV band to connect the satellite with the hub or the gateway stations. And on the other side, we're using the KA band for the user beams. Yes. With that higher frequency bands, we can get more bandwidth resources so that we can have high throughput to transmit data. And when we use the satellite links for the backhaul scenario in the 5G networks, you know, in a single 5G cell, it could be maybe more than 1 gigabps at least, yeah, for just one cell. So we must have a high throughput in the satellite link to match the 5G base station backhaul scenario. Of course, it's not the only scenario we want to support. But yes, I think the high frequency band is a trend that we integrate the satellite system into the terrestrial networks in the future. Yeah.
Okay, now that makes sense, and I think it's part of this gradual transition of satellite going towards higher frequency bands, and something that is being kind of pushed also by the C-band reallocation, which we can discuss more also. But yeah, so Raymond or Lon, any thoughts from you on I guess Q-band versus V-band or Ka-band, different so the appropriateness of different frequency bands for?
Yeah, I think from if we're looking at from a geo perspective, I think QV band, we see the merits when it comes to definitely allowing higher throughput, more bits per hertz. But what we are also concerned about is in Asia in particular, I guess the ring fade, ring attenuation could play an important role when it comes to designing a satellite. So as a satellite operator, it's important to look into our current resources. I'm talking about orbital resources. What are the bands that's available when it comes to designing a network? Whether it's a GEO, it's a LEO, what are the bands that's usable, and how can we create an efficient network? And we have to look at it holistically and then not just focusing on a single band, because every operator have their own resources and they always have their own network concept as well. So I think this is what I'm thinking right now.
Okay.
And I agree with Raymond and Wang, what they've said. The way we look at Q and V, we think, and I feel sometimes like I'm the old man on this panel to talk about how this is a natural evolution anyway, just like satellites went to Ka band. And although we really haven't made a full transition there, they're being used more and more for new applications. The great thing about Q and V is that there is a lot of capacity there. And yes, there is a rain fade issue, but for those services that really do not have no latency requirements whatsoever, you could even put up with some kind of rain fade, because you really can push through an awful lot of information because there's so much bandwidth there. So I think it's inevitable. I think as we need more and bigger bandwidth, we are going to be drifting toward Q and V as well. We'll keep our other bands. I hope, you know, we've lost some of the C, unfortunately, but I'm hoping we can hold on to the rest as a satellite guy, but Q and V is important in the future.
Yeah, and I think that, you know, going back to your earlier point about how with 5G, we're going, you know, satellite is going to be connecting these different nodes, and implicitly there will be higher throughput per site, I suppose, you know, more capacity per site. And I wonder if that will, to some extent, decrease the rain fade issues, in the sense that you'd be getting just a lot more bandwidth per site. But certainly it's an interesting topic. So just the last.
Can I just make it clear?
Sure.
There's still rain fade the higher you go. That's not the issue. The issue is that if latency is not as critical, you can keep on pushing the information until it gets there, and you can deal with the rain fade.
Yes. Okay.
Sense?
Yeah.
Okay.
That makes yes.
All right, and also you can have more power too, which also compensates. But, so there are a number of ways to take care of the rain fade. I'm not saying it's not an issue, but the more bandwidth you have, the more power you have, you can overcome it with applications that are not so sensitive with regard to time.
Understood. And so just one more question on the network element of this. So we've talked a little bit about latency and about inter-satellite links sort of indirectly, but I mean, what are you as a company or as I guess personally, but what are your thoughts on inter-satellite links and the sort of the necessity or lack thereof of inter-satellite links for addressing 5G and for kind of building the 5G network into the sky, as it were?
Are you asking me first?
Sure. Well, we can go down the line. Yes. Yeah.
Go back and forth, and Raymond stays in the middle the whole time.
Yeah.
Yes.
But you can ask him first if you want. Anyway, when it comes to inter-satellite links, they are inevitable. It's being worked on by all satellite manufacturers, and I think that one of the advantages that they're going to bring is as we have more and more traffic going over in these 5G networks for security purposes, rather than keep on switching through the ground, this may make more sense for certain kinds of communications. So I think there'll be more and more demand as we go forward. The other thing, arguably, it makes communications faster, satellite to satellite to go around the world and all that. That's important too. But I suspect it's going to be security issues that are going to drive the need for it.
Okay. Raymond, any thoughts on inter-satellite links?
I agree as well. I think that the security issues and also the local regulatory issues probably play a part in the whole inter-satellite link as well. So how do we connect them, and how do we make sure that everything is by the books? I think those are the challenges that we're going to face. But inevitably, I think that's the future.
Okay, and Wang Peng, is Galaxy Space using inter-satellite links at the moment, or do you plan to use inter-satellite links?
Yes, currently we have our first satellite in orbit. So in that satellite, of course, we don't have the inter-satellite link. But yes, we are designing the ISR in our next generation satellites. And we also know there must be some critical topics. For example, how to design our roads protocol between the satellites, how to construct the network based on those ISRs. And yes, we think inter-satellite links could make our whole network frameworks be more flexible, and for the long distance transmission, it could make the data transmission even faster than the fiber on the ground. So yes, we think the next step would be the inter-satellite links will be applied in our LEO constellations. Yeah.
Okay, thank you. So just just to quickly summarize kind of the network that we have just described, and then I do have one more question on the network, so I apologize, I lied before. But just to make sure, so we have a 5G network that is going to be very, very high bandwidth. There are going to be a lot of, we could call them nodes that need to be connected, but it probably will not be a fully global 5G network, at least terrestrially. And it will be enabled partly by satellites that can offer highly secure and high speed and reliable connectivity. And the network is going to be very smart, and that's going to require flexibility of capacity. And so I guess my last question about the network, and then we'll switch over towards applications, is, and Wang Peng just mentioned it briefly, but this issue of flexibility of capacity and flexibility of the network. So you can have inter-satellite links that can allow you to kind of transfer capacity from one satellite to another via these links, but you can also have flexible beams, or you can have reconfigurable beams. So just at a high level, I would like to ask, what are your companies doing about, network flexibility and bandwidth flexibility and trying to get more capacity out of your, I suppose, CapEx dollars, as it were, in this new world of these very efficient, smart networks?
I can start first.
Okay, great.
Yeah, I think that's something that we are definitely thinking about. We've always been talking to our suppliers and manufacturers, or even ground equipment partners, that how can we define the next generation satellites, right? So things that you just mentioned, beamforming, digital channelizers, all those things that we are thinking about. There's definitely cost involved, whether you want to go for a conventional band pipe versus a beamforming type of advanced technology. Then we need to look at the overall trade-off when it comes to how much we can get out of the investment for our shareholders. So yes, but in the future, I believe the market is evolving very quickly. Things are changing, and the new applications are coming up. And sometimes it's very difficult for the operator to design a satellite that could serve the customer need in the next 15 or 20 years. So certain flexibilities built into the network is definitely essential when it comes to the future satellite design.
Oh yeah, 15 or 20 years at this particular point in time in 2020.
It's like a
that
lifetime.
Sounds. Oh, I mean, it's like, I can't imagine 15 or 20 months from now, much less 15 or 20 years.
I know.
That's yes.
But imagine as a satellite operator, we build $100 million, $200 million of assets, and you're going to be there for 15 years as a design.
Oh yeah.
Life, for example. So how do we manage the change in dynamics? That's going to be $1 million question, right?
At least $1 million, yes. Okay.
It's more than that.
Yes. Okay. Lon or Wangpeng, any thoughts on network flexibility?
For the from the technical point of view, I think for the flexibility, we need to make our satellites smarter. Yeah, we need maybe more powerful OBD on the satellite itself, and also as we mentioned just now, the satellite system is integrated with the networks on the ground. So maybe we need to see how the satellites could be used in the overall network slicing, or something like the edge computing technologies be designed in the satellite systems. Yes, I think it's quite similar as the networks on the ground. Actually, it always some common points from the network or framework point of view. Yeah, I guess we can borrow a lot of good technologies from the existing 5G network. Yeah.
Okay, thank you.
And I just want to say what Raymond said about the challenge of the satellite business. This has always been this challenge of the satellite business, in that you fix a design, then you have to build to it. You fix a design 3 years ago, so it's already becoming somewhat obsolete, and at least that's how you feel. And then you launch it, and it's another year to launch it, so finally it's up and you're using it, and then it's an asset that's going to be there for 15 years. And it's always been the challenge of satellites. So how do we fix that challenge? Well, what manufacturers are looking at, including Lockheed, is how do we make the satellites, as Long says, how do you make them smarter? And in particular, it really comes down to how software defined can you make the satellite, which then allows the ground segment to be the one that helps manage the system. And that's ultimately what we have to get to. Now, as far as the difference between bent pipe and really smart satellites, well, sure, I mean, bent pipe are going to be cheaper, and in certain instances, it may actually be a benefit to 5G, to the extent we're looking at just distribution of content as far as we can to the 5G nodes. So it may have a benefit there. I mean, I don't want to put down simpler satellites, but to the extent we want to focus our capacity as best we can and also be nimble enough in the future, the future is how a lot of processing and a lot of ground segment that can manage the processing from the ground. That's the future, and we're working on it.
Yeah, and I mean, I guess if we take a step back and just really think about, what is the value add of telecommunications networks or of satellite in this particular day and age when everything is going online and many services are becoming digital? I mean, the value add is basically having some amount of connectivity or bandwidth at a given time at a given place. And that's it, pretty much. And so if we think about satellite and its advantages, which is just, sorry, go ahead. I may have oversimplified that.
But in the 5G world, if I can just, I'm not countering it, but I'm just making a point about.
No, you're welcome. I mean, I welcome countering as well.
No, but in the 5G world, the way I describe it, I'm being a little parochial about North America. I apologize. We could talk about Asia as well. But imagine if all the ice melts all of a sudden in the North Pole, and all this water is coming down all the rivers in North America. It couldn't handle it. And that's what we're facing now. We have systems, we're going to have so much more usage as a result of 5G. We're going to need every pipe that we can get. And if what the focus is going to be is urban and suburban areas, there's going to be a lot more need for satellite when it comes to the further areas beyond that for 5G. Now, I'm not overstating at all how much more capacity is going to be going through all these pipes worldwide. And there's going to be, at least in the near term, a very strong need for satellites through we're already seeing it increase. In fact, I saw an article recently where all the satellite companies, or the major ones, are saying, hey, we're doing fine. COVID-19, there's more and more capacity need as a result, and it's only growing. And we're learning how to work at home more. We're rushing 5G as fast as we can. And they're doing just fine with satellite companies because there's this need. And I think you're going to just see it grow.
Yeah, so just a quick point to highlight, I think that's the longest I've gone into any webinar in 2020 without hearing COVID-19. I think you made like 25 minutes. That's pretty good.
I'm sorry.
No, and to your point though, I mean, I think you're right that that there's going to be a lot more there's going to be a lot more bandwidth requirement. And I think what I was trying to say earlier, and I didn't perhaps put this as well as I could have, is I mean, the value add, I think, will still be just, connecting somewhere at some place. But if we think about the world in 5G, there's going to just be so many more opportunities to do that. I mean, if we think about what's the total addressable market size for connectivity, I mean, some deviation of the number of gigabytes consumed or something. I mean, it's the amount of data people are consuming. And so I think if we consider the value proposition of satellite or of the network in general to be, providing megabits per second or gigabits per second at a time at a place, the more gigabits per second being consumed in the broader variety of areas, I suppose that would be the better for satellite. I think so. Yeah, I think we're on the same page there in that we're seeing a lot more bandwidth being consumed, and having that right bandwidth at the right place at the right time, I think, is going to be a big value add for satellite.
That's wonderful.
Yeah. Yes. Yeah. Okay. So moving on to different applications. So this is fun because it kind of lets you think about outside the box a little bit about what is this future of unlimited bandwidth everywhere going to look like. So I guess starting off, I mean, when we think about the buzz phrases around 5G, we hear about industrial IoT, we hear about autonomous cars, we hear about, well, those are probably the big two. Do you see any specific applications or any specific use cases as being, very appropriate for either geo or for non-geo, for your company and what you're trying to do right now? Yeah, any?
Okay. As for the application point of view, actually we are we are designing some a kind of a system which can use the satellite broadcasting feature more efficiently in the networks. So you know, the 5G network has some trouble with the coverage and also with power consumption. We all know that. And also, when we deploy the 5G networks, we traditionally we are using the fiber cables on the ground. So in that case, when we have a broadband satellites, I mean, the capacity of the satellite can match the 5G bandwidth requirement. We have opportunity to use the broadcasting feature of the satellite to push the content in a wide range to maybe lots of base stations simultaneously, which can offload the transport network and balance the network. So that's what we are designing to how to use the broadcasting in network. Yeah.
Yeah, that makes sense. And I suppose as the terrestrial network gets bigger, as there gets to be more data going through the terrestrial network, the opportunity to balance the network, as you said, will be larger. It's more, in terms of the amount of data. That's a good point. It's interesting that you mentioned doing that from LEO.
I just want to pick up on.
Yes, go ahead, Lon.
I'm sorry, if you have a different place you want to go, that's fine.
Nope, all good, go ahead.
Okay, I just wanted to highlight one point that Wang said, excuse me. And I'm fascinated by this sort of back to the future aspect of this, is that part, as we've already identified, part of the design of these 5G networks will be all these nodes that are further and further out. And it's going to become important for them, if they're going to provide 5G service, that they get a lot of content that they're going to store there. As memory increases in each node, they're going to be able to store information there, and then it gets accessed. A lot of content is content that everybody accesses. Everyone wants the headlines in particular news. Everyone wants certain things that if you look at it, the amount of content that everyone accesses, it's duplicated quite a bit. And so what satellites, and this is the point about broadcasting, it's almost going back to the time when satellites were perceived as these large broadcasters, but instead we're going to have much more focused beams on a particular area delivering content. But the point is, that's what satellites can do best. We can broadcast and get content. And now that those nodes will have so much more memory capacity, they're fine with the satellite. And it allows for us to push content further and further out as efficiently as any other technology. So it's actually an exciting opportunity for satellites.
Yeah, I agree.
Go ahead, sorry.
I remember when I was in the PANELISTS days, we had a product called Store and Forward. And this is basically putting the service at the edge, right? Which satellite does the best. So I think satellite in itself can definitely complement we can complement the 5G network in that way as well. And maybe we can even potentially, some of the computing can be on the edge as well. So we offload the traffic on the backhauling as well as probably improve the efficiency or the latency of the whole network when you're using the satellite.
That makes sense. And going back to something that Wang Peng had mentioned about the video offload to these sites from LEO, just to kind of dig into this a little bit, kind of the benefit and drawback of LEO versus GEO in this case. So I mean, with GEO, certainly there's the there's the point to multi-point, and I very much like the Back to the Future idea here, where we're saying, okay, well, satellite before it had this great value proposition of broadcasting a video feed to many places, and that still exists, but now we're in this digital age, and you can broadcast the same digital signals to same bandwidth to many places. From LEO, I suppose you have you have certain disadvantages and certain advantages. So Wang-Peng, do you want to discuss a little bit more, I guess, of the video offload from LEO, and how you I don't know how you see that scaling, how you see that developing, and then maybe we discuss a little bit more about the geo side and sort of the benefits and drawbacks of each one.
Yeah, regarding to the offload the traffic, as Raymond just mentioned, the edging computing, or we see MEC in the 5G or 4G networks, which already being used. Yeah. And when we broadcasting the video content, maybe not only video, but also some other. For example, you may have some game content or something like that. We broadcast them, and we apply some MEC nodes. It could be deployed in the terminal sites. I mean, satellite terminal, and also it could be even in the satellites themselves, if we have enough memory or a cache resource in the satellite itself. So I think regarding to how to broadcast the same content, we must apply it with the MEC together, which can make the network more efficiency. Yeah.
Okay, and just one last quick question on that first satellite that you have launched. If I recall, the total throughput was like 10 or 15 gigabits per second on the LEO, the test satellite, if I'm not wrong. Out of curiosity, are you able to tell us about how many beams that satellite is, or kind of how that capacity looks when you are when you're doing tests? If you're not able to share that information, I understand. I don't mean to put you on the spot, but I'm just curious about that satellite. Yeah.
Okay. I can tell. We have 16 user beams. Yeah, which they are using Ka band signals, and in our testing, we have demonstrates that each of the beams have more than 1 gigabps capacity, and currently, actually, we didn't hit the limit of the capacity yet. So it could maybe it could be even higher, and of course we have 2 QV band antennas as well in the satellite. So basically, the total capacity of the satellite could be higher than 16 gigabps. Yeah.
Okay, thank you.
Mm-hmm.
Okay, Lana, Raymond, anything from your side on I guess GEO versus LEO in terms of applications or latency, as it were, or anything on GEO LEO, anything interesting that you'd like to bring attention to from, I guess, the satellite test that Galaxy Space has just done, or any other thoughts on GEO versus LEO?
If I could just go to, first of all, I don't really think of any of this as GEO versus LEO.
That's a fair distinction, or a fair, yeah.
Okay, there's satellite applications. I understand there is a latency difference, but there's also a latency difference between terrestrial facilities and any satellite facilities. And there are certain applications that latency is critical. For example, I see you have down here autonomous vehicles. Well, I think we all know, and I'm pretty sure no autonomous vehicle is going to be using, as they're going down the road, anything other than a very localized node on the road as they're operating. But that doesn't mean there isn't a role for satellites, and there, for sure there is. There's diagnostics, there's billing, but it's not because of latency. No one's using satellites as a result of whatever latency, the difference between LEO and GEO with regard to autonomous vehicles. Now, that being said, and I think some of the, I've seen great technologies in all the different bands. Also, by the way, MEO as well. I think it comes down to how much capacity anyone may have and how inexpensive they can make it. Because I think all these satellite systems are going to be providing the fundamental things, whether it's backhaul, redundancy, communications to the edge. All those things will be done by various satellite systems, regardless of GEO or LEO.
Yeah.
That make sense?
Makes sense.
Yeah. One size doesn't fit all in what we are looking at right now, right? And as satellite operators or partners, we can actually work together to see how can we actually get a part of the business when it comes to 5G going out in different parts of the world.
Okay, that makes sense. So moving on to, I guess we covered a little bit already Q and V band, but I guess the so frequency bands in the context of 5G, one of the major talking points around the world with 5G is the repurposing of some of the C-band spectrum that has historically been for the use of satellite operators, and repurposing that spectrum for terrestrial 5G. And this has already happened in some places like Hong Kong. It is currently it's the U.S. is moving along in that direction, but I guess to the point of C-band repurposing, and as I mentioned a little bit earlier in the webinar, this is kind of part of a broader trend for satellite going towards higher frequency bands. But do you see any opportunities that exist in the repurposing of this C-band spectrum from a satellite operator perspective, either in terms of well, I guess reusing, using that C-band capacity elsewhere if it's over a large area, or otherwise opportunities in having satellite operators needing to go towards higher frequency bands? Do you see any opportunities here?
Well, I guess C-band actually is a very critical spectrum that for our industry, right? That we're definitely losing some of those variable spectrums. But I guess if we look at the applications, especially in Asia, a lot of critical telecommunication is based on the C-band network. And also our day-to-day life entertainments, whether you are watching it through your cable head ends, I mean, those are all through C-band distribution network. I think in general, I think we should continue to support and fight for retaining the C-band spectrum for some of the mission critical applications. But there's definitely a way that we could smartly redeploy some of the C-bands, just what you just have mentioned, whether it is creating potentially a regional beam, multiple spot beam, that what kind of resources we have, and understanding our customers, how they are using the spectrum in different parts of the world, can give us potential insights. How can we further monetize the spectrum accordingly? Well, I mean, moving to higher frequency probably is inevitable, but protecting the C-band is also very important.
Okay. Anything from Lan or Wang Peng on C-band in the context of 5G?
In the context of 5G, I understand why certain countries in the United States see it as a spectrum to be used for 5G. I have to tell you, as a satellite guy, I feel like C-band is a good band. It is a useful band. I know, as someone who sells satellites worldwide, that it is important for the whole world, I'm sorry, not the whole world, it's important in many, many parts of the world and still remains a very viable band. So I don't know how much of this is going to happen throughout the whole world. I know there is a concern that if there is success in the United States about repurposing it, that other countries will follow suit. I suppose that is the concern, and that's an understandable concern. I don't see it as totally linked with Q and V bands, but, and this is the silver lining, if the world, and it really is up to the world to allocate the spectrum, if the world says, well, we don't have that, but the world really does want satellites, and I'm very confident that they will continue to want satellites, and I'm very confident in the 5G world, even more so, then they will start clearing more and more bands in other places, including the QV band. So that's the silver lining. And I believe it's going to happen that way. C-band, I don't know how much is going to change worldwide. That still remains to be seen. In the United States, it's pretty certain, but that's really all I know.
Okay, and I don't know if it's just my screen, but I think Lon is frozen on his screen. Oh no, there you go. You're unfrozen now. Okay, very nice.
Oh, am I frozen?
You were frozen for a moment, but it's okay. Okay. Yeah, Wang Peng,
Yes.
anything from you on C-band, or otherwise we can move on. But if you have any thoughts on C-band, that would be welcome.
Not much from me because we are using Q and V and KA.
Right. Okay. That's it. Yeah. Okay. So I guess going into the last topic, and this is it kind of relates to applications, but I guess when we think about the 5G world and the COVID-19 world now in 2020, and everything, or many things are going online, many services are becoming digital, and it seems from my vantage point here in Hong Kong that there are a lot of very big online platforms that are getting a lot of market share for things. There's a lot of consolidation going on in this kind of digital world that we're all moving into. And it has kind of led me to ask the question of who in the future, who is the ultimate end customer for satellite operators? How do satellite operators choose to vertically integrate or not? So, I mean, for example, if we think about a very long-term future where hypothetically, let's say a Project Kuiper were to come to fruition, were to launch into orbit, so you have Amazon having its own LEO constellation, their end customer, I would imagine, for a lot of that capacity would be Amazon Web Services. I mean, that would be a sort of a vertically integrated play to a certain extent. And you could make a similar argument for Tesla, for SpaceX, Starlink, saying, they want to upgrade their Tesla network over the internet. I mean, a tenuous argument, but similar nonetheless. So I guess just in terms of thinking about who the ultimate end customer is and what does the market really look like in sort of the medium to long term, I mean, are we still looking at the telecommunications the telcos as the biggest possible customers for this type of capacity, or are we starting to look at the big tech companies, or are we thinking about different types of customers, different ways of vertically integrating? I understand that's kind of a broad and sometimes nebulous question, but any thoughts on who is our ultimate end customer, and how do we kind of make sure that we can keep our spot in the value chain, I guess?
I could venture a guess, at least with the manufacturers, that the manufacturers, at least the one that I know, is looking at its sales as if you're going to call it a vertical sale. It's no longer selling a satellite, it's selling a system. And it understands that in order to be successful and to differentiate ourselves, our system has to be as extraordinary and as promising as 5G is. And that's what Lockheed is focusing in on. So I'm at least to that extent. But then, and now I'm just speculating to answer your question. I can imagine as part of that, whether you are the manufacturer or you are an operator, you begin to develop your own end user products. So for example, an operator may have designed a great IoT system or something like that, and that they say this is the best device, it goes best with our satellite system. And then there are thousands of these deployed, or sensors that are deployed. And also the sensors, one could argue, if they can be connected very specifically with the satellite, they may be able to provide certain security as well. So it's that kind of integration, both by manufacturers and by operators, that has some potential.
Yeah, I mean, to that point, and I don't want to speculate on what would be a terrifying and pretty concerning thing to see, but I do have to kind of wonder, as everything is going digital and as we all kind of take for granted cybersecurity to a certain extent, would some horrendous terrestrial network-based hack of some kind, I mean, might that at some point lead to people saying, holy crap, satellites with inter-satellite links, or even just with secure non-inter, I mean, that security element, I would imagine, will become a lot more significant in the future. I mean, I don't know. I don't give a lot of thought to my own.
No, actually, one of the things, the more dependent we get on our 5G devices, the more we have smart cities that have smart grids, that have smart power grids, that need to make sure that everything is talking to one another, you will see them depending on satellites for one form of redundancy. We're not going to provide the service and be the primary provider, but we will be a redundancy for at least critical communications, and people will pay for that to make sure that the satellite system is around.
Mm. No, that makes sense. Yeah, that makes sense. Okay, anything from Raymond or Wang Peng on vertical integration or on security? In my mind, I'm just envisioning again, like some horrendous hack of the terrestrial network, and then being able to say, well, we have this fully controlled network over here where we have a gateway that is guarded at all times. We have a very secure gateway, and we have secured user terminals, and we have secure links between everything. I don't know. I mean, you don't want to hope for a horrendous cyber attack, but if that ever were to happen, I would imagine you'd get a lot of people coming towards satellite potentially.
I think in general, if you're thinking about IoT, right, that the number of devices is just crazy. Millions, I mean, tens of millions of devices that we're monitoring. We are monitoring probably humidity, the temperature. I mean, I don't know what we are monitoring. The oil pipes, everything is being monitored to one way or the other through the IoT devices. So vertical integration is definitely potentially a possibility for operators, whether you are working as a GEO or LEO or a MEO, where you try to design something that actually fit with your network. That is in conjunction with potential hardware manufacturers that could actually make it compatible with whatever satellite device, satellite that you are planning to build or trying to launch.
Okay, thank you. Wang Peng, anything from you on this topic?
Just one thing I'm thinking because we know in the 3GPP standards, actually satellite technologies is already being involved in there a lot of discussion. So we can see in that standard the IoT via satellite is already being listed, and of course, it will use low frequency band resources. Yes, and also there is some scenarios discussed in 3GPP about the vertical industries, how to use the satellite in there. So I don't have some particular idea maybe, but I think because the 5G is facing to vertical industries itself. So we need work together to find out the right scenarios and to make our design in the future. Yeah.
Okay, well, that sounds good. And I believe that we are just about reaching the end of our 1 hour. So I would like to thank all of the excellent panelists on the webinar today. If you'd like to contact any of our panelists, you have their email addresses here. And do we have any closing thoughts? Any last remarks? I'm good from my side, but if anyone has anything that they would like to let the world know, we've got about 2 minutes.
5G is coming faster than anyone can imagine. That's all I can say.
I think so. Yeah. I guess just one last question. I lied again. So 5G in China, I think, is rather more advanced right now. I'm in Hong Kong, but I've lived in mainland China for a number of years, just not this year because it's hard to get over the border. Wang Heng, in China right now, is 5G? Are there 5G networks in most cities in China now? I mean, has China entered the 5G era, could we say, or is that still further on?
I think in many cities we have in China, operators has already installed some 5G base stations, of course, and maybe in the city areas, and also some people are already using the 5G smartphones. Yeah, so but we know it will be a huge cost to construct a 5G network, and I think it's very difficult to make the same coverage as before. I mean, for 3G and 4G, yes. So, but anyway, in China, 5G is a very big thing, and the government and the enterprise is a hot topic in China right now. Yeah.
Do you have a 5G phone yet, or not yet?
Personally, I'm still using 4G, but you know, in June this year, when we testing our satellites, we tested the 5G backhaul scenario. So I used the 5G phone for some days. Yeah, it's quite fast. Yeah,
quite fast. Well, we heard it here first. It's quite fast. Excellent.
It works.
Okay. Yes. Yeah. Well, thank you all for your time. It's been a great discussion, and I hope that our audience has enjoyed it as well. And do come back next week for the next APSCC 2020 webinar, and we hope to see you again soon. Thank you.
Thank you. Thank you, Blaine.
Thank you.
Bye.
Thank you. Bye.
All right.
Thank you for that, Blaine. And thank you very much, Lon. Thank you, Raymond. And thank you, Wang Heng, for your participation in today's webinar. Also, thank you very much to GeoShare for sponsoring today's event. And we do appreciate their support. Please tune in next week for the next installment of our webinar series on APSCC 2020 Live series. That'll be on big rockets and small satellites. First of our launch services panels, brought to you by Arianespace. We'll feature Arianespace, we'll feature SpaceX, and China Great Wall Industries. Look forward to seeing you then.